Today, we would like to propose our site selection for the new BCG vaccine plant. In this presentation, we'll talk about the key criteria for identifying potential sites.
Some of the key stakeholders are locals, NGOs, users, private investors, and government. Here are some of the key factors to be considered: electricity/power access, freshwater access, transportation lines, accessibility of basic building raw materials, impact on the environment, disasters like earthquakes, fires, and floods, accessibility for workers, geology, and telecommunication. For electricity generation, we need 5 megawatts of power, preferably using renewable energy sources for sustainability. Solar energy, for example, needs 67,000 meters. Hydroelectric plant needs to be near a river, and wind power is dependent on weather and could result in inconsistent power.
Transportation was also one of the key aspects which we took into consideration. Employees need to be able to reliably commute to and from work, and improving transport networks will greatly benefit locals in the area. We aim to try and utilize as much existing infrastructure as possible to maximize cost efficiency. Buses are cheap and adaptable, and the cost of building roads is $450,000 per kilometre. Alternatively, trains are more environmentally friendly and could be used to haul building materials needed for the site. However, at $4.12 million per kilometre, it is definitely more of a long-term investment.
For our vaccination plant, we need a clean, consistent water source because it is used in the manufacturing process and will allow everything to be kept clean and safe. There are a number of lakes and channels in Uganda. However, most of the sources have some degree of pollution, and therefore some sort of treatment may be required. The main method to access the water is via wells, which tap into underground water deposits or rivers and lakes nearby.
Picking the right soil to build the vaccine plant is important because it makes the construction process cheaper, easier, and makes sure that the foundation does not fail in the long term. Uganda's soil is mostly made up of sandy loams, sandy clay loams, mineral hydromorphic soils, saline soils, and ferruginous tropical soils. The ideal soil to build on is loamy soil. Loam is a mix of silt, sand, and clay, and it is ideal because it holds water at a balanced rate, it allows for air circulation, it absorbs moisture, and it has evenly balanced properties to support foundations.
It is important to choose the location in close proximity to sources for the required raw materials to reduce transport costs and emissions. The main material we will need for building the vaccination plant is concrete, which is made from cement, water, sand, and gravel. Water and sand are obtained from rivers, being pumped from reservoirs and mined from the riverbed, respectively. Cement will be obtained from third-party manufacturers, which are in all 3 of Uganda's main cities. Gravel will be obtained from quarries by crushing rocks like sandstone or limestone.
We've got 3 options for the site. For option 1, we're going to use a lake as a water source and hydropower for the electricity source. For option 2, we're going to use a river for a water source and solar panels as electricity source. However, we will recommend option 3, which is in Ambabara, Oscar. It is near to a Rizi River, which we are going to use as a water source for the vaccine process. We'll filter it to get clean water. We'll use the solar power for electricity sources, which are renewable, as well as environmentally friendly. We can use the Ambabara Northern Bypass Road for transportation of vaccine, raw materials, as well as workers. The plant will be built on sandy loam, which is the ideal kind of soil for construction. As for the disasters, there are no earthquakes in the area. However, the area is prone to landslide when there's rain, but this can be fixed by using strong foundations. The area has access to 3G internet connection, which is useful for communication.
We picked this option because compared to option 2, it is not close to any residential area. Therefore, the vaccine plant will not disturb local communities. Additionally, we decided to use solar power rather than hydropower because dams for hydropower degrade rivers by blocking their flow, and they flood huge areas, forcing many people from their homes. Therefore, we picked option 3 with solar power rather than option 1. In conclusion, we optimized our criteria to find the option that is the most cost-effective, sustainable, and practical, and we feel that the Mbarara site is the best option. Thank you, and here are our citations.